In the last video we looked at how to derive the equation of motion v equals u plus at. And what we did was we started with saying that acceleration is just equal to dv by dt, and we set up a differential equation. In this video, I'd like to look at how to derive the equation of motion s equals ut plus a half at squared, because I think it gives a bit of intuition about how the equation works and how it's formed. So we start with v equals u plus at. So here we have the velocity at time t, which is that, equals the initial velocity plus the acceleration multiplied by the time. And that's all that says. So we have this equation. Now let's rewrite v in another way, and v is just ds by dt, where this is the rate of change of displacement. So this term here is the rate of change of displacement, which equals velocity. That means we can rewrite this equation like this: ds by dt equals u plus at. So again we have another differential equation that we can integrate and solve for that. So we have ds by dt equals u plus at. Now, multiplying through by dt, that gives us the integral of ds equals the integral of u dt plus the integral of at dt. Now, if we integrate these, we get, well, the integral of ds with respect to ds, so it's 1 with respect to ds, is just s. The integral of u with respect to t is just ut. And the integral of at with respect to t is just a half at squared. We mustn't forget that we will pick up a constant of integration, so we'll put that in there. So already we have something here that looks very much like what we want. In fact, it's exactly what we want, but we have this constant of integration that we need to deal with. And to deal with that, so we have s equals ut plus a half at squared plus c, is we consider the initial conditions. So we say, well, when t equals 0, s equals, well, in this case, s will equal 0 when t equals 0. And then so we put in these two values into this equation, and we get 0 equals 0, because we're substituting 0 into here, and we're substituting 0 into here, plus 0 plus c, so therefore c equals 0. And then we can say that s equals ut plus a half at squared, and that is our equation of motion. So we now have two equations of motion that we've derived. We've derived s equals ut plus a half at squared and v equals u plus at.